Hey everyone. To make it easier for you, I'm going to go through this PowerPoint and you can just pause it so you can take as much time as you need to write your notes on your paper. You should have already downloaded the paper Biome Notes for PowerPoint and have that paper with you as you're going through this recording. All right, let's get started. So first of all, what's a biome? We've probably heard of it before. They're large areas that are characterized by a certain type of climate. And because of their climate, they have certain plant communities. So if you look at the picture on the left, you probably can look at that and say, oh yeah, that's a tropical rainforest. How do you know that? It's the amount of water that's there and it's the temperature. And therefore, certain plants can live there. On the right-hand side, again, it's based on the amount of water and the temperature, and that determines the types of plants. And you can look at that and say, okay, that must be a hot desert. So we usually describe a biome by its plants. And why do we care about plants so much? Because the types of plants that live in an area determine the types of animals that can live there. So we usually talk about plant communities. And the climate is what determines what type of plants can live there, and then also the type of animals. When we talk about climate, we're usually looking at long periods of time. And when I say long periods of time, I mean 30 years or longer. What are the average weather conditions in an area? So weather is just today. How much rain is there? What's the temperature? But over a long period of time, it's climate. Okay, here's something interesting. We've always said this is over a 30-year period or longer. But today, that's changing because of climate change. So the insurance industry, they want to know, what are the chances that your home is going to get hit with a hurricane or a tornado or a flood? And they determine the rate you pay for your homeowner's insurance based on the chance that your house will get damaged. They've always used 30 years of data. Except now with climate change, what happened 30 years ago doesn't really matter. Even 20 years ago, it doesn't matter. They're now using 10 years of climate data to figure out what are the chances that your home is going to get hit with a storm and get damaged. So right now our definition is still 30 years or longer, but conditions are certainly changing. So climate, it's weather conditions. Okay, what determines weather? Well, one big thing is temperature. So organisms can only live within a certain temperature range. So temperature is very important. Precipitation also. All organisms need water. So the amount of precipitation determines what organisms can live there. And, large organisms, including plants, need more water. So if you're in an area and you're seeing trees, that means there's quite a bit of precipitation there because those large plants need a lot of water. If you're in an area and there's no large trees, that means there's less precipitation. So we can put this all on a gradient. So if we're going up, here I am at the bottom left-hand corner working my way up. This goes from hot to moderate to cold at the top. Along the bottom, from left to right, wet to moderate, all the way to dry. And if you look at all the combinations of those, you get 9 different combinations. And those are the 9 main biomes around the world. You can see them all on this chart. Now, that's not the only thing. It's not just, well, it is basically temperature and precipitation, But there's some other things that determine the temperature and the precipitation. So let's go through those. One of them is latitude. So the equator is 0 degrees latitude. And as you head north or south, it gets colder. So latitude for whatever region of the world makes a big difference in temperature. So does altitude. As you head up a mountain, I'm sure you're familiar with this, it can be quite warm at the base of the mountain, but when you get to the top, it's really hot. It gets really cold. So temperature goes down as you move up in altitude. So we can put this on a gradient as well. So latitude, as you head north or south, it's getting colder. As you increase altitude, it gets colder. And this can also form a gradient. But it's all coming down to temperature here. Now, global air circulation makes a big difference. And we're going to look more closely at these topics coming up later in a future unit. But for now, you can just look at this. This is a picture of the heating of the Earth, and you'll notice all along the equator, it's red. That means it's warmer there. The equator gets the most energy from the sun, and the poles get the least energy from the sun. So that uneven heating of the Earth leads to global winds and also regional climate, so it affects the biomes. Now, our planet is tilted on its axis. So as we go around the sun in 1 year, there are times, like our summer, where we are tilted towards the sun, and during our winter, we are tilted away from the sun. So this impacts the angle that the sunlight hits the planet. Sometimes it's hitting us on at 90 degrees, and sometimes those solar rays are hitting us at less than 90 degrees. And that impacts how much heat is in the sun. And we will talk about this more closely later on. So this is what we call insolation. It's how much energy are those rays from the sun carrying. When it's a direct ray, it's 90 degrees and it's got more energy in it. That would be during our summer. So right now, we're still in summer, we're getting direct rays from the sun. An oblique ray is when the solar energy is hitting us at an angle, and it doesn't have as much energy. You know this because you go out on a summer day and you stand in the sun, you'll get really warm. You know those rays from the sun are carrying a lot of energy because you heat up quickly. Go out on a winter day and it's not, this solar energy doesn't have as much energy and it doesn't have as much heat. So you don't get as warm as you do on a summer day. And it's all about the angle that that solar energy is hitting you. So this is what we call the equator versus the thermal equator. The equator of the Earth is 0 degrees latitude. That doesn't change. That is a point on the Earth's surface, right at the widest spot of the Earth. But thermal equator changes by the season. So we are right now at thermal equator in summer. We are getting those 90-degree light from the sun. So the sun has more energy in it. In our winter, we're not at the thermal equator. So this impacts the temperatures in an area. Now, not only does it impact temperatures, it also impacts precipitation. So this is the equator right down here, and it's getting the most solar energy. Actually, at the equator, it doesn't vary. It gets about the same solar energy throughout the year. They have no summer or winter. But as you head north or south, the angle that the sun hits you, as well as some other factors, change a lot. And the amount of energy that you get throughout the year can vary a lot, but not at the equator. It's pretty consistent. So the sunlight hits the Earth at the equator. And what does that energy do? Well, one of the things it does is it evaporates water. So the air is very moist and warm. And what happens to warm things? They rise. They're less dense, so they rise. And what happens as things increase, as you go up in altitude, it gets colder. So warm air can hold more water than cold air can. And so as this warm, moist air rises, it cools and it can't hold as much water. So it rains. That's why it's so rainy and wet at the equator. So air rises, drops its water. Now it hits the top of the first layer of our atmosphere, the troposphere, and it can't go any higher. It's almost like a ceiling. So the air has to either move to the south or it has to move to the north. And it's dry then, and it sinks because it's cold. And what happens to cold things? They're less dense, they sink. And they sink at around between 20 and 30 degrees north and 20 and 30 degrees south. And what do we have with this sinking dry air? It gives us deserts. But as the air went down in the atmosphere, it heated up. So it's a hot desert. And then the air starts moving back towards the equator. It picks up moisture, and then it's warm and it's moist and it rises and it drops its water, and you end up with these convection currents. This also impacts the biomes. You have the moist, warm areas at the equator. You have dry, hot areas between 20 and 30 degrees south and 20 degrees north because of these convection currents. Now, I just described to you what's called the Hadley cell, north and south of the equator. These are these typical air currents, convection currents that happen. But there's more. There's other convection currents between 30 and 60 degrees north and south, and then other convection currents at the poles. So we have all of these global air circulation patterns that impact the biome. Basically, temperature from how much energy the area is getting from the sun, and this impacts how much precipitation happens in an area. So if you follow along the equator, you tend to get warm, moist areas. Between 20 and 30 degrees north and south, you get deserts. And then we've got rainy areas, again, between 50 and 60 degrees north and 50 and 60 degrees south. We tend to get these patterns. Now, of course, the mountains impact things. This is simplified why we have these patterns in certain regions of the world. But because of all these factors, we end up with these biomes. So they've added one more biome in here with mountains. But the rest of them on this map are the 9 different biomes that we see. So you tend to see the tropical rainforest, lots of rain, very warm along the equator. Here's the hot, dry deserts along 20 to 30 degrees north, 20 and 30 degrees south. And then we end up with rainy areas again, 50 to 60 degrees north, 50 to 60 degrees south. And then the poles are cold deserts. And you might say, what? That's not a desert. I've seen pictures of all that ice. It does rain in deserts on occasion, a little bit every year. The thing is with the poles, that precipitation gets trapped in ice, and then it just doesn't go anywhere. So you have thousands and thousands of years of ice, little bit every year, trapped at the poles. So it actually is a desert. Here's another diagram just showing how the precipitation can impact the different climates. So it's temperature and precipitation. And what determines the temperature and precipitation, otherwise known as the climate of an area? All those factors we just went through. All right, you can now use this information to answer the questions on your note paper. Make sure you submit it. You can submit a document if you typed your answer. If you hand wrote everything, then take pictures of each page and submit that. All right, I will see you back in class.